Hi, Andrea here. Today we will talk about the scientific method. The scientific method is the scheme according to which science moves forward. It has been rigorously formulated for the first time by Galileo Galilei. In its treatise called Il Saggiatore, Galileo says, "Philosophy is written in this great book that continuously open before our eyes, I say the universe, but it cannot be understood if the language and the letters in which it is written are not learned. It is written in mathematical language, and its letters are triangles, circles, and other geometric figures, without which it is humanly impossible to understand a single word of it. Without this, it is a vain wandering through a dark labyrinth." For the first time, there is a precise indication about an objective description of the nature. The aim of the scientific method is to define a procedure for the explanation of the reality using measurements and quantitative analysis. Today, the scientific method can be depicted as in the following. Everything starts with a question about the functioning of the phenomenon of interest. Then there is the formulation of a hypothesis capable of explaining the phenomenon. In order to test the hypothesis, an experiment is performed. In the end, the results are analyzed and the conclusions about the hypothesis are drawn. It is important to notice that if the results do not match with the hypothesis can be rejected. In the other case, if the results are in agreement with the hypothesis, we cannot say the hypothesis is right once for all. It is just currently accepted. In fact, future experiments could show some limitation of the used theory, and so we need to move toward a better description of reality. This is the very base schema to discover something new. Now, let's make an example. Galileo was the first to state that any body falls due to gravity with the same velocity. This may seem counterintuitive. In fact, in the everyday life, a leaf falls far more slowly compared to a brick. Indeed, Aristotle was convinced that a falling body hits the ground with a velocity proportional to its mass. But the reasoning by Galileo was something like this. If I tie together the leaf and the brick, I would expect a more massive object, falling faster than the brick alone. But I can also expect the leaf impeding the motion of the brick, resulting in a slower movement. Just think about the leaf as a parachute. In order to check his idea, Galileo tested the motion of bronze balls of different sizes over an inclined plane. The reason behind the usage of such a plane lies in the difficulties of a direct measure of the free fall time of an object, given the technology available at the time of Galileo. An object that falls vertically falls quickly, and it's hard even to see, while the same object rolling diagonally allows an easier time counting. So, during his experiments, Galileo saw that balls of different sizes rolled in the same time along the inclined plane. To conclude, the vertical freefall can be thought as the limit case of a vertical plane. In other words, in the extreme configuration of a very inclined plane, we go back to the vertical freefall case. So, we can say that any object falls due to gravity in the same way. This is our first step in the study of nature. Other situations can be approached in a similar fashion. In any case, you will surely learn how to make your own discoveries.